We can compare the size or length of different things using simple words like large and small, heavy, light, long, short, fast or slow. But the problem with all of these words is that they are relative descriptions. You need to have something else to compare it to. If I tell you that I would like a large cup of tea, well, that's one thing. But if I start talking about Wivenhoe Dam being a large dam, that's a whole different kettle of fish. So what we really need for useful measurement is to have some absolute units. We need to compare everything to particular, commonly available or agreed objects or things. For example, there are practical units like the foot, hand, hide, bushel, egg, bath. Do you know what each of these is used for measuring? Look them up. You might learn something new. For measuring time, there's the day, which is clear enough, but we also have months, seasons, and years. How long is a month? It used to be a moon, 28 days more or less, but now? And how long is a season? 3 months, you say? There are plenty of places in the world where there's only 2 seasons, wet and dry, some where there are 3 seasons, and even a few places where there's little discernible difference in the weather throughout the year. And then there's all the mess with leap years. The real problem with commonly available or commonly known units is that they might not be quite as common as you think. Here's a comic from a physics textbook that illustrates the problem. The knight is trying to lift a sword that's far too long and heavy, and the blacksmith, who evidently has very long feet, is saying to the knight, "I'm sorry, my lord, but you did say it had to be 4 feet long." So what people have done historically is just agreed on some arbitrary thing to be the unit for comparison. We make up a particular bag of sand, or a specific size and weight of coin, or the distance between 2 specific towns. It's completely arbitrary, but it works. If you need to know, you just go and compare it to the reference bag of sand, or even make a new bag that's exactly the same as that one, so you can take away your own reference copy. Our modern metric units in the SI system are no different. SI stands for International System. The letters are in the opposite order because it's actually a French abbreviation. The SI units are based on agreed definitions. There's a physical bar kept locked away in carefully controlled conditions that is the definition of how long a metre is. The second is based on the length of the metre and the speed of light in a vacuum. Please note carefully the spelling of metre, which is spelled RE, not ER, because it's a French name, and the abbreviation for the second, which is a single S. Note also that these abbreviations are lowercase letters, not capitals. SI units are divided up into fundamental and derived units. There are 7 fundamental units, of which here we are interested in only 2, length and time. All the other units are derived from these fundamental units. That's things like kilometres and millimetres, hectares, litres, and for time, minutes, hours, milliseconds, and so on. Many of the derived units in SI are based on standard prefixes that multiply the unit by a particular power of 10, usually a power of 1,000. Yes, there's rather a lot in this table, and it's still not complete. Most of the time, you really only have to know these ones here. The others are necessary for specific situations or for general studies in fields like physics or engineering. But you really should know all these ones highlighted here. Kilo, meaning 1,000, and mega, meaning 1,000,000, along with centi, meaning 100th, and milli, meaning 1,000th. Note the abbreviations for each of these, and in particular that capital or lowercase makes a significant difference.